Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In this video, we're going to talk about stable lubrication from the book Strictly Mechanical Engineering Design. Okay, so what is a stable lubrication? Okay, the chapter start with difference between boundary and hydrodynamic lubrication. Okay, the difference between boundary and hydrodynamic lubrication can be explained by reference to figure 12.4. This is the figure 12.4. Okay, this is figure 12.4. You can see the thin film and thick film. Thin film is state as unstable and thick film is as stable. Okay, this plot change in the coefficient of friction versus bearing characteristic. Okay, you have learned in the previous slide the Sommerfeld number. Okay, there is an equation for Sommerfeld number, which is we will do the example in the next video. Okay, uh, this bearing characteristic was obtained by McKenzie brothers in actual test of friction. Okay, the plot is important because it defines stability of lubrication and helps us understand hydrodynamic and boundary or thin film lubrication. Okay, this is the graph. Okay, let me explain. This is the example of a shaft. Okay, you can see if you put the oil, the grease full of this, the full of this, it become thick. Okay, if you pour water into a container, the water is full of in a container, meaning that the container is thick of full of water. If the water is only on the surface of the container, meaning that it is a thin film. It's like if let's say if you I try to give an my best analogy. Okay, let's say this is a container. You pour water, okay, inside the container, and then it become full, and then it is thick with water, okay. Likewise, if the level of water is so thin, only a layer, it become thin. Okay, so okay, if you for the condition of general bearing, it is better to become thick, better become thick of water, because if you put anything, let's say on the case of this water, you put your toy boat. Okay, okay, you put your toy boat, okay, on a thick of water, it can flow smoothly. But if you put the toy boat in just a tin of water, okay, water level is not that deep, so the boat cannot flow smoothly because the hull of the boat, the bottom of the boat uh, touches the bottom of the container. I This is the analogy given. Okay, this is an analogy given. Um, I give this analogy to make you understand. Okay. To the left of line BA, the decrease in viscosity will increase the friction. Temperature rise will ensure, and more viscosity will be reduced still more. The result will be compound. Thus, the region on the left will be A, represent unstable lubrication. So, we want stable lubrication. Okay, we want to avoid unstable lubrication. What contributes to unstable lubrication? Imagine you go to your service car, you go to service your car, you go to service your motorcycle, okay, and then the mechanic says that this oil is for 10,000 kilometer. This oil for 5,000 kilometer. Okay. After service, you can see the oil become dark. Okay. Okay. The oil become dark. Okay. Why does the oil become dark? Okay. It is because the effect of heat, metal and metal contact and everything. Imagine in that car, in your car, heat rises. When you drive your car, it it generates heat, and this heat will burn the lubrication oil, and then when it burn, it become chemical reaction and become carbon. And when it become so much carbon, that is why the reason that you have to change your change your lubrication oil regularly according to the specification that as suggested by the mechanic. Okay. uh, uh, then when the film, okay, become uh, thick, become thin, after 10,000 kilometers, your car have to service, because the film, the lubrication oil become thin. Okay, initially it is thick. Now, of because heating, because become carbon and everything, so the film become thick, thin. And when the film become thin, it happen is metal to metal contact. Okay, your journal bearing will contact to the bushing, and then it will, some of the particle of the bushing will come out little by little by little bit by little bit, until it wear the bushing, and also it wear the journal. This we must avoid. Okay, this is why we must avoid, because friction generates heat. Okay, so this is the reason that we should avoid thin film. Okay, unless the lubrication oil is is being researched to become the purpose of thin film. Okay, actually thin film, you need uh, a better lubrication oil, a better technology to make it thin film. Okay, because there are ongoing research. Some of my friends are doing nano lubricant using graphite and many things. Okay, meaning that thick film, the problem with thick film is too oily. Okay, we have to do maintenance, we have to clean everything. So the ongoing research is going for thin film. Okay, no, using minimum quantity lubrication, so that uh, the amount of uh, lubricant is can be minimized, while not the journal not becoming metal to metal contact and everything. So it is an ongoing research. Okay, so uh, for the normal services, uh, better use thick film. Okay. Okay, this is what I tell about metal to metal contact. Okay, as you learn in your physics class, when metal, when two surfaces are in contact, it generates heat, and when it generates heat, it become wear and tear, and also friction will happen. So this is what we want to avoid. The consequences is that if you do proper maintenance, maybe the cost of operation, the fuel consumption, the electricity consumption is, let's say, $10. Let's say, okay. If you do not do proper maintenance, then metal to metal contact happen, and friction will happen. The cost will become $15. Okay. Let's say I just give an example, meaning that uh, we want to avoid it. Okay, metal to metal contact is, we want to avoid it. Okay. The same goes as when you are servicing your car. When the mechanic says you have to service after 10,000 kilometer, you go and service at 10,000 kilometer. Okay, because if you don't care for your car, uh, the some parts of the car will have metal to metal contact, and then your car will have a shorter long life. Okay, your engine will the engine will become shorter life. Okay, so this is what we want to avoid. Okay, so that's all for this video today. We're going to do in the next video on thick film lubrication. Thank you very much.